Hey guys, and welcome to topic 9 and 10 on weathering, erosion, deposition. So this is two chapters that are small, kind of put together. All right, so just some do now questions to think about. What is meant by weathering, and how does weathering happen? All right, so obviously we're going to be answering those questions in a moment. So you just think about those for a moment if you want to pause and think. All right, but as we go through this, we will answer those questions. So weathering is basically the breakdown of rocks into particles called sediment. I know you guys hear the word weather in there, all right, because weather does some of this, obviously. But it's not just weather, it's other things on the Earth's surface, all right? So weathering occurs when rocks are exposed to the following things. The atmosphere, all right, so obviously that's the weather. Hydrosphere, which would mean the water sphere of the Earth, as we learned. And the living things, all right, including ourselves, all right? So we obviously have some effect on the Earth and how things break down. All right, there is a brain pop. You guys can feel free to click that link, and I think your Google accounts are linked to it, so you can log in. All right, so types of weathering. So the first type of weathering is physical. It's a breakdown of rocks into smaller pieces without chemical change. So obviously it's a physical breakdown, a mechanical breakdown. That's the other word they use, mechanical weathering they call it. So in the first case here, we're looking at root action. All right, so roots, we always think of anchoring, but also in anchoring, they are exerting pressure on rocks. And obviously rocks won't always stand up to this pressure well, and they'll break apart. So in the case of this tree growing into this rock, it's breaking it apart. Same with here on the cliffs. There is some roots anchoring the cliff together. However, those roots are going to channel for water, and eventually it's going to break apart that rock. Right? So these won't stay here forever, these bluffs. And that's why they have these safety fences here. All right? Because you don't want to step on the edge there. All right, so plant roots grow through cracks, break the rock apart. Okay, second one, frost action. That's when water freezes and expands in the cracks of the pavement or rock material. As this happens over and over again, the rock is going to break. All right, it can't stand up to all that pressure. This is sometimes also called frost wedging because it makes a wedge shape when it goes into the material. All right, so you obviously get little cracks in the rock. And that can be from other things happening. The water will go in there. It will freeze. When water freezes, it expands, and it takes up more space when it's an ice. So what does it do? Well, exerts pressure on the rock and breaks it apart. This happens over and over again, and your rock will crumble. That's why your roadways look like bad in the springtime. All right, after our winter freezing and thawing, you see a lot of potholes. All right, it's not just the plows, all right, it's also the freezing and thawing that's happening. So obviously on colder winters where you have that freezing and thawing happening, you're going to see more of that. All right, exfoliation. This is also referring to changes in temperature that cause the rock to expand and contract. So not necessarily frozen, but it could also just be temperature changes that rapidly happen. So this can even happen in warmer climates a little bit. Rocks will break from the expansion and contraction of the rock. Abrasion. Abrasion, I always think of abrasion on my knee. So an abrasion is like a scraping. All right, so it's when rocks rub against other rocks or sediment and basically grind apart. All right, good example of this is called sandblasting. All right, if you've ever been to the beach when it's windy, you've been sandblasted. So what happens is sand material gets blown against the rock, and then basically you can see here it leaves grooves in the rock. Sometimes frost and pits the rock a little bit. We'll talk more about that in a little bit. But it definitely will break apart the rock slowly. All right, so deserts tend to see this a lot, obviously. A very dry environment will have that very commonly happen. All right, there is a mechanical physical weathering video. You guys can click the link for YouTube for that. All right, I'm going to move on to chemical weathering. All right, this is the chemical breakdown of rock. So breakdown of chemical action that results in the change of a mineral composition. All right, so there is a chemical reaction that happens here. All right, so first example is called oxidation. All right, and it sounds like the word oxygen is in there. All right, that's no joke. That's the reason why it happens, because elements react with the oxygen. All right, so good example, iron plus oxygen. It's not just the water kind of helps it along, but iron plus oxygen will give you iron oxide, which is also known as rust. All right, so this rusty nail here is showing that. So it's the oxygen that's breaking it down slowly. The water kind of helped it along, basically. All right, hydration. This is when elements in the rock react with water. Water is known as a universal dissolver. All right, it dissolves most materials. So feldspar, an example, it will combine with water molecules and form clay material. So clay are fine particles that are usually wet, and you can see this sometimes, especially in our area here in Port Jeff, by the bluffs. All right, you'll see clay material down the bottom here from all the rainfall that trickles down. Okay, carbonation. Elements are dissolved by acid rain. Okay, so acid rain breaking down rocks such as gravestones. All right, that's a prime example in some of the questions. So why can't you read the gravestone anymore? Well, this may be made out of marble, and marble, you guys know, is made of calcite. Calcite reacts with acid rain, so you can't read the letters anymore. All right, so carbon dioxide plus water makes carbonic acid. Sulfuric dioxide plus water makes sulfuric acid. And those come directly from rainfall, and it's from our pollution that goes up in the atmosphere. And so we're the culprits of acid rain. Obviously, it's getting worse and worse as pollution goes up, and that's the reason why that happens. So here's an example of it. So your factories putting those particulates, even the trucks, right, cars, you name it, goes up into the atmosphere. Rain physically clears the atmosphere of any particles, and that falls as acid rain because it's cleaning up all those particles that are in the atmosphere, and they combine with the rain droplets, all right, which become acid rain. Oh, and one more thing. So you can see here it affects also not only rocks but also trees, all right, and you can sometimes see this when you're driving to places. You'll see trees like that are twigs up towards the top, and the bottom parts still have green. All right, that's from acid rain. And then fish obviously will be affected also, in animals. Okay, so chemical weathering, you have a video also to watch. All right. All right, now what affects the rate and type of weathering? Okay, so exposure obviously. So whether or not the rocks are exposed to air, water, and living things will determine how fast the weathering is going to be. So therefore, rocks near the surface are weathered, and rocks deep underground are not. So if you increase the depth of underground, you're going to decrease the rate of weathering. Okay, so that's an inverse relationship there. All right, particle size. So particle size, the smaller the particle size, the greater total surface area that is exposed for weathering. The more exposed weathering, the easier it is to break down. So smaller material will break down faster than a larger piece of material. So a boulder will take a long time to break down compared to a smaller sand particle. All right, so you increase particle size, you decrease rate of weathering. Also an inverse relationship. Okay, mineral composition. Different minerals have different resistance to weathering. So, great example, hardness. All right, you guys know this from rocks and minerals. Quartz is hard, so it takes a long time to weather. Talc, on the other hand, is a soft mineral, so it will take a shorter time to weather. So you increase mineral hardness, you decrease rate of weathering, so also an inverse relationship. Climate is a different situation. There's a lot of different factors with climate. So in warm, moist climates, chemical weathering is going to be dominant. Cold climates, frost action is going to be more effective. Whereas a lot of freezing and thawing, there's also going to be frost action as the most effective form of weathering, right? Because it definitely breaks apart rocks quickly. Dry climates, very little weathering is going to happen, but when it does, it happens pretty rapidly because that environment is bone dry usually, and if they do have rain, it will erode away quickly or weather away. So a couple things here. So rate of physical weathering. So if you increase temperature, you decrease rate of physical weathering. If you decrease temperature, you increase the rate of physical weathering because frost action is king in the cold climate. Whereas chemical weathering, you increase temperature and moisture, you will have more chemical weathering because of acid rain. All right, lastly, products of weathering. So weathering results in 4 different types of sediment. So solid sediment such as sand and pebbles, so different size sediment. Colloids, clay-sized particles, which are your smallest size of sediment. They can also be silt-sized sometimes too. Ions are particles dissolved in water. So salty ocean water has ions of salt particles dissolved in there. And lastly, soil is a mixture of sediment and organic matter, right? Which we're going to talk more in depth in the next set of notes. All right, so that's it for weathering. Thank you guys for tuning in, and see you next time.